looking at the second passage, you realize that you only have 6 minutes to read and understand what you're reading and answer these questions. So you've got to move quickly. That's why 10th graders this year and some other grades have been working in Reading Plus at all of our schools, trying to increase your ability to read quickly and understand what you're reading. That's so important in a timed test like the ACT. So let's go with number 6 and get started. The passage states that according to the Standard Model, there's some key words, the interaction between fundamental particles and the Higgs field is what gives particles blank. If I go over here and I look, I soon find this according to the Standard Model. If I keep reading a little bit, I find that term, that interaction is what gives particles mass. So there's your answer. Clean, simple. It's the biggest breadcrumb you could find. Here's your answer. It's what gives particles mass. Going on to number 7. In the extended metaphor used to describe the Higgs field, what metaphoric equivalent is used to describe the fundamental attribute that provides the quality of mass to objects? So I'm going to go down here and I'm going to look for something that looks like a metaphor or in some way describes things and compares them without using like or as. If we go down here, we see that British theoretician John Ellis likes the Higgs field to a flat field of snow. Okay, it says he likes it to it. That means he is comparing it to it. But he's not coming out and saying this is like or that is as something. So it is a metaphor because it's not using like or as specifically. So he's talking about this flat field of snow, and he talks about how getting across in hiking boots you would sink because of the heaviness. Snowshoes would be faster, or skis, and that would affect how this particular type of particle passes through the Higgs field. So if we look at that, we're seeing snowshoes, skis, and hiking boots used in this metaphoric equivalent. They have here as choices snowshoes, skis, and skates. We said nothing about skates. We did say snowshoes and skis, so your answer has to be 1 and 2, letter C. Going on to number 8. The Higgs field differs from electromagnetic or gravitational fields in that the Higgs field blank. Okay, now if I go over here and I look for this electromagnetic and gravitational fields, and that's what I'm looking for, electromagnetic, gravitational fields, and you've probably already found them, and I am searching. And I'm not finding, and this is here. Okay, the Higgs field is exactly the same everywhere. Here is, unlike magnetic or gravitational fields, which vary from place to place, the Higgs field is exactly the same everywhere. So there's our answer. We found the magnetic and gravitational fields. Took me longer than it should have. It's a good thing I'm not taking the ACT right now, but this is why you're practicing. So we know that it differs in that it's the same everywhere. So, is measurable on macroscopic scale, doesn't say anything about that. Only is observable between subatomic particles, doesn't say anything about that. Has the same intensity everywhere. Notice it says, is the same everywhere. Okay, so there's our answer, I believe. But we'll look at D. Has a direct correlation to radiant energy output. I didn't read anything about that. So C is my answer. And then in number 9, in addition to the international nature of CERN, the body that runs the LHC, the multinational nature of the project, multinational, more than one nation, is reinforced by the fact that the LHC is physically located in the countries of. So at this point I know I'm looking for the names of countries. and I start scanning and I see Switzerland, but I keep scanning for 2 countries or 3 countries, and there they are, Switzerland and France. It is traversing the border between Switzerland and France. So my answer would have to be A, Switzerland and France. Now look at number 10, the last one. I know you're thrilled. Don't scream for joy yet. One useful metaphor for the Higgs field, according to one British theoretician, is to compare the Higgs field to what? Well, if you look over here, it talks about the Higgs field. He likens it to, or likes it to, a flat field of snow. So we have a field of snow, infinite smooth wall, sheet of rubber, motionless film of oil. That one's very simple. It gave you the answer straight out. So we're finished up for today. Thank you for your time. Continue to work hard on these. Continue to spend some time on the internet working on ACT problems. It will make a huge difference for you when you take this test.